Good morning, children. Welcome back to the science class. In the previous class, you have learnt about the radiation. Today, you are going to learn about the applications of radiation and also a magical bottle. What is a magical bottle? Can you guess that? First, I am going to tell a simple story. From that, you can understand about that magical bottle. One winter morning, Tom and his family went to a picnic spot. Now it was winter. Anyone would like to have a hot coffee or a hot tea. Now Tom's mother took out a bottle-like thing and served them coffee. And coffee was hot. Tom started wondering that it was around 1 hour they had reached the picnic spot until the coffee was so hot in this bottle. Now, what was inside this bottle that was keeping the coffee so hot for such a long time? This bottle kept the hot liquid hot for a very long time. Not only this, but in summer, he noticed that his father was using this bottle to keep cold water because this bottle was to keep cold water cold for very long time. So, Tom asked his mother about this bottle. How does this bottle keep hot water hot and cold water cold? Then his mother told him that it was a magical bottle. Now you can understand about that magical bottle. Yes, a magical bottle is a thermos bottle, thermos flask or a vacuum flask. Yes, today you are going to learn about the thermos flask or a vacuum flask. Let us study about the thermos or vacuum flask. It consists of a double-walled bottle made of thin glass with the inner surfaces of the bottle silvered or polished. Air is pumped out of the space between the walls to create vacuum, which is done by this opening and then it is sealed. The mouth of the flask is closed with cork or plastic. The glass bottle is then placed in a metal or plastic case and it's supported on corks at the side and at the bottom. I am going to explain the parts again. Mouth. It is cork or plastic. Case. Metallic or plastic case. Double-walled bottle. Double-walled bottle made of thin glass. Vacuum. This is a space between the walls. It does not have any liquids and gas. Corks. These corks are supporters for this thin glass bottle. Now we are going to study about how this flask minimizes loss of heat by convection, convection and radiation. This is a detailed answer, so all must be careful to learn this answer. First one, the content of the flask lost minimal heat by convection, as glass, cork and vacuum are poor conductors. It minimizes the transfer due to conduction. Second one, the space between the double walls too is vacuum and does not have any liquid or gas. Therefore, there is a little loss of heat due to convection. This vacuum is also reduce the convection. Third one, silver surfaces. Finally, as the inner walls of the glass bottle are silver, any heat radiated is reflected back into the flask. So, silver surfaces reduce the radiation. The substance in the flask therefore retains its temperature. That is, it remains hot or cold for a long time. First one, the heat loss minimizes by conduction because glass, cork and vacuum. These things are for conductors. So, it will reduce conduction. Second thing, vacuum. So, it will reduce the heat loss by convection. Third one, silver surfaces. It will reduce the heat loss by radiation. Let me ask you a few questions. First one, what type of clothes should be worn in summer? White and light color clothes are worn in summer because they do not absorb sunlight and hence keep us cool. Second one, what type of clothes should be worn in winter? Black and dark colored clothes are preferred for winter because they absorb sunlight and hence keep us warm. Third one, what is the function of the reflecting surface provided in an electric room heater? In an electric room heater, a polished reflector is provided behind the heating element of reflect radiant heat towards the front. These are all the applications of radiation. Let us revise the whole thing. Conduction, convection and radiation. First one, conduction takes place without actual movement of particles. But convection takes place through movement of particles. Radiation, it does not need a medium. Second one, conduction is slow. Convection is also slow, but the radiation is fast. Third one, conduction transferred in any direction, but convection transferred upwards and downwards. But the radiation transferred in straight lines. Now you can understand about the Thermos flask very briefly. Today's assignment. Draw a label diagram of a Thermos flask. Explain how it minimizes loss of heat by conduction, convection and radiation. Thank you.